All right, so here's our example. It says, a ship leaves port at noon and heads due west at 20 knots, or 20 nautical miles per hour. Okay, so 20 knots is nautical miles per hour, right? So 20 nautical miles per hour. So then it says, at 2 p.m., the ship changes course to N 54 degrees W. So again, you got to understand what that means. That's 54 degrees west of north. Okay? Now, find the ship's bearing and distance from port at 3 p.m. All right. Okay, so now, let's draw the picture. So it says, we leave a port going due west, right? So let's say the port is right over here. Okay? We're going due west. We start at noon. Okay? Then at 2 p.m. it changes course to 54 degrees west of north. Okay? So here's north. We're going 54 degrees west of north. So let's say we're doing something like that, right? Okay, and so this angle here is 54 degrees. Okay? And 40. Okay, so it's going, oh, and it gives us the speed. It's going 20 knots, right? The speed, 20 knots, which is equal to 20 nautical miles per hour. Okay, so now, how much time has passed since it left the port and to the time that it changed direction? Well, 2 hours, right? Started at noon, changed direction at 2 p.m. So that's 20, that's 2 hours. So it's gone 40 nautical miles. So 40 nautical miles. Okay? And what do we know? So we want to know at 3 p.m., so an hour later, right? So an hour later from here, goes here to here, an hour later, how far has it traveled? Well, it's traveled another 20 nautical miles. So we know that side, right? Now, the question is, we want to know the bearing and the distance from port at 3 p.m., which is when it arrives right here. So we need to find that distance and the bearing. Well, let's figure it out. We can figure out we got this right triangle, but we also can make another right triangle here. Let's extend this out. Okay. So we got another right triangle there. Which makes, well, it actually makes a large triangle here, right? So we got a large right triangle here. So if we can find this distance here, then we can use trigonometry to find this distance here. So we're going to have to find this length. but we need to find an angle here. Well, the cool thing is we've got what? Two transversals. This horizontal line and this horizontal line. We've got, or not two transversals, we've got two parallel lines with this transversal, which means alternating interior angles are congruent. So this has to be 54 degrees. Okay? And we know this length here, we need to find this length here. So again, this is going to be sine, right? So to find L, we're going to find L. So this is going to be sine of 54 degrees is equal to opposite over hypotenuse. So L is equal to 20 times the sine of 54 degrees. All right, so let's figure out what that is. Okay, so let's do 20 times sine of 54, and that's going to be 16.18. What do they want us to round to? Let's see, it says round to, they don't say it round, so let's just do it. So it's going to be 16.18, so approximately 16.18 nautical miles. Okay, so that means this length here is now going to be 16 plus 40, so that's going to be 56.18 nautical miles. Okay. Now, we know this angle here has to be complementary, right? Because it has to form a right triangle. So this angle here has to be 36 degrees, which means this angle here has to be 36 degrees, which means what? This angle here, the whole thing, no, that's not right. Something's not right. Oh, no. That can't be right, because that's not a parallel line. Okay, let's double back here. Oh, let me see, let me think. So this has to be 36 degrees, which means that, yeah, that's right. So this is 34. We need either this angle. Let's see what we get. What do we got here? 54. Think. Let me think. Okay, so it's staring me in the face. Okay, so we know this side. We need to find this distance. Okay, let me think. Ooh, why? It's eluding me. Okay, so 90, So 144 144 Okay, let me think. Okay, let me do this. Let me. Let me think. You know what? Let's do this because I'm going to have to do more and more stuff. Let's do this. Let's find this side here. I was going to try to find the angle, but you know what? And to find this side, but we're going to have to do another step. Let's find this side because we can easily find that side. We'll call this S. And so let's do sine of 36 degrees equals S over 20. And so S equals 20 times sine of 36 degrees. And what do we get when we do that? Okay, so so 20 times sine of 36, 11.75, so 11.8. Let's call it 11.8. So approximately 11.8 nautical miles. Okay, so now what we can do is, now we've got this length and this length. So let's find this angle here, called theta. Okay. And so in order to do that, we're going to have to use tangent. So tangent theta equals opposite over adjacent, so that's going to be 11.8 divided by 56.2. Let's just round it to 2. And if you take the arctangent of both sides, you get theta is going to be approximately equal to 11.8 degrees. Okay, so this is going to be 11.8 degrees approximately. All right, so now Okay, so now we want the angle from north, right? Because we want from the north-south line. So we're going to have to subtract this, right? Because we want to see what the bearing is from the north straight line. So we need to find this angle here. So we're going to subtract 11.8 from 90, and we get 78.2, right? So 78.2 degrees. All I did was take 90 and subtract off this angle to get this angle. So this is going to be our bearing. So the bearing of the boat is going to be what? It's going to be west 78.2 degrees, or excuse me, I'm sorry. North, 72.8 degrees west. Okay? Now, we still have to find the distance. So now what we're going to do is to find this distance, we're going to take sine of, sine of 11.8 sine 11.8 so we're going to have to do sine of 11.8 is equal to S which we got 11.8. Okay, so it looks like that's the same. So 11.8 over D. So D is going to equal 11.8 over, in fact, let's do this because we don't want to use approximated. So let's just put this whole thing over here. So we're going to do 20 times sine of 36 degrees, right? Because we want to calculate it all. We don't want to round until we get to the very end. So instead of using this, let's just plug in what we did here. And then over sine of 11.8. That's the only way we can, this one we have to use it. We can't get around that one. And so now if we plug all of this in our calculator, we should get approximately 57.4 nautical miles. Okay, so the distance from port is 57.4 nautical miles, and the bearing from the port, the ship, is 78.2 degrees west of north. And that's it. Have a great day.